Hello everyone, welcome back to the channel. Welcome back to our Java DSA series. Now, as you know, current topic that we are discussing is linked list, right? Now, as part of this video, we are going to understand a very important question related to the linked list, right? Which is asked in so many interviews and it is a very interesting topic, very interesting question. So yeah, let's get started with the topic. And in today's video, we are going to understand about how to reverse a linked list. It's a very classic question. So before I show you it in the code, okay, there will be a method like public void reverse, which will call down this linked list object, and after that method is executed, your list will be reversed. Before I actually code it, I want to show you the representation of it, the graphical representation of it, where you will see, okay, this is how the pointers are getting changed and your list is getting reversed. So let's see that first. Let's have a look at this. So before reverse write, our list looks like this. So our head points to 10, 10 points to 20, 20 points to 30, and 30 is our tail node, right? Now after reverse, our list should look like this. So 30 should be our head, 30 points should point to 20, 20 should point to 10, and this 10 should be our tail, right? And 10 next pointer should point to null. Now let's see how you can actually do it, and let's keep our explanation very simple, right? So this is the list that you have right now. We have taken few pointers in our question, which is first pointer we have taken is previous, second we have taken as current, and the third pointer we have taken as next node, right? So what you want to do with each iteration, right? You want to make sure that our current pointer should point to the previous node, right? So that is the objective. So we keep on iterating one after the another, right? And with every single iteration, our current pointer should keep on pointing to our previous node. So that is the objective that we have right now. Now how do you achieve it? Let me show you that. We make use of this single line, current dot next is equal to previous. There are these other lines as well, which I have written right here, right? So we'll be discussing about these as well, but let's focus on these first, second and third iteration, right? In first iteration, as you see, based on this line, right, current dot next, this current dot next is equal to previous. With first iteration, our 20s started pointing to 10, right? And this 30 is still in memory because 30 is still pointed by the next node, this next variable, right? Now in the next iteration, when your current pointer becomes previous and the next pointer becomes the current, again your current pointer is pointing to the previous node. So this link is again got changed. Now your 30 points to 20, right? Now again at the next iteration, now your current pointer became previous and the next pointer became current. So now as you see with this, at this iteration, right, third iteration, now your current is null. Now the moment your current pointer becomes null, now you have reached the end of the linked list, right? That is when you stop your iteration, right? The moment your current is becoming null, you are stopping the iteration, right? So currently your 30 is pointing to 20, 20 is pointing to 10, right? But currently you still have this single pointer, right? But 10 is still pointing to 20, although 20 next pointer is still pointing to 10. So you don't want this 10 points to 20, right? Because after your list is reversed, this 10 should be our tail node and its next should point to null. So with every single iteration, what we are doing, our current dot next was pointing to previous, right? And we were changing the pointer of current and previous node, right? So in first iteration, 20 starts pointing to 10, this pointer. Now in the next iteration, 30 started pointing to.
Okay, so first we check when the list is empty, we are throwing the no such element exception, list is empty, right? And then we are actually creating those temporary nodes that we discussed just now. So how the implementation will go? Let me repeat that. So you have three nodes, right? 10, 20, 30. with every single iteration, your current's next will point to the previous node, right? But when your current pointer next is pointing to your previous node, right? At that time 20 was pointing to 30, right? So you have to make sure that this 30 is also held by some particular node. So that is where your next node will come into picture. So previous, this 10 is being held by previous, current 20 will be held by this current node, and 30 will be held by this next node. So that when you're changing this link of current node, right, current dot next to previous, that is when 30 is being held by that next node. Now let me show you that in implementation, then I will give you a recap as well. Node, so you see I have created a temporary node previous which is pointing to head. Let me create a current node. Now this current node is pointing to head dot next, and now let's have a loop. What will be the continuation to terminate this loop? So we'll terminate this loop when current becomes null. That means this current point, right, this reaches the end of the list. When the current will become null, right, at that point of time this previous will be held by the last node in the linked list, right, which will be our new head. So let me show you that. So while current is not equal to run, that means we reach the end of the linked list. What we want to do till that time, with every single iteration, we are having one more road, we are naming it as next, and this is holding the value of the next node from the current node, right? So why we are doing this, why we have created a variable which is holding the next node from the current node, so that when current's pointer we change, right, so we don't lose the value to its next node, we don't lose the link to its next node. So the moment you do this, right, current dot next, this starts pointing to your previous node. So now to make sure that you don't lose the link to your next node, you are creating this temporary node. Now all you have to do, you just have to shift these three pointers, right, previous, current and next, to the next iteration. How you do that? You do that by pointing previous to current and your current to next. Now you are already iterating, right, you keep on changing the pointer, but two things are still remaining, which is your head and tail pointer. So now let's say you have that 10, 20, 30, right, where 10 was your head and 30 was your tail. Now after reversal, 30 should be your head and 10 should be the tail node. And how you do that? So we know that head is being pointed by 10, right, and we can make it tell here itself before even this iteration or after also. Just to keep all these lines at one place, I'm keeping it here also. So what I'm trying to do, I want to make 10 as tail node. For that, the straightforward line would be tail becomes head. That's it. And remember, when you are iterating, right, in first iteration when you change the 20s next to 10, right, at that time also 10 was pointing to 20. So to remove that link, once you make 10 as tail node, right, what you will do, you will make tail dot next to null, so that you remove that link between 10 to 20. Now all you have to do, you know that you need a new head which is currently 30 after reversal. So 30 is currently in previous node, right? So previous will become your new head. There you go. That's it. Let me give you a recap. Okay, before recapping, let me check if our implementation is correct or not. For that, let's uncomment this method list.reverse. Let me delete whatever we have here. Then let me refresh. Run. So now you are supposed to get first this 10, 20, 30 and then 30, 20, 10. Okay, you're getting that, right? That means our implementation is perfect. You are able to get the correct answer, and even if you go ahead and execute this piece of code on LeetCode also, right, you will get this particular implementation is better than 99% of the implementation on LeetCode. So just understand this particular implementation. Let me give you a recap. So first, what we check, if your list is empty, you will throw a no such element exception. Then what you will do, you will create those two temporary nodes, which is previous and current. Previous will hold the head value and current will hold the next value from the head. Then you will iterate through your until your current node becomes null. That means until you iterated through end of the linked list, right? Then what we did, we created a temporary node next, which is pointing to current's next node. And why we did this? So that when you change this pointer like current dot next to previous, that 20 to 10, right? So that you still have the link for your next node, right? So that you don't lose your next node. Post this, right? What you do, you make previous to your current node and current will point to next node. You keep on doing this until you reach the end of the linked list. When you reach the end of the linked list, at that point this previous will hold the value of your new head, that is 30. That's what we're doing here. Now we are changing to those head and tail pointers, right? Now we know that 10, which was earlier pointing to head, now it should point to tail, right? So we change that pointer, we made that head pointer to tail now, right? And tail dot next, that means that 10 to 20 which was pointing, right? That link we removed and we make sure it is null, right? And then our new head pointer is 30, right? So to make sure 30 points to head, we know the previous value is holding the 30 node, right? We make sure this head points to our previous node now, and your list is reversed. That's it. That was the implementation. I hope you are able to understand this. If you don't understand this or you feel any complexity, feel free to comment. I'm more than happy to explain it again. Okay. So yeah, that's all we had as part of this video. Just try to understand this particular piece of code and see you in the next video. May the source be with you.